Hello.
Hello, how are you?
Okay, I'm going to be in a commute for like 10 minutes, but then I'll be able to say more in about 15 minutes or so.
Okay.
So,
Yeah, I was interested in hearing about I see you have a new post on your Substack, so maybe we can go over that.
yeah, I was trying to basically take some of the audio from our original discussion about it, and I realized the audio was just too trash, and I spoke too poorly, so I redid it. But I wanted to include you in it because you're part of the discussion and all that stuff. So more about that later. Yes.
Okay. Yeah. All right, that sounds good. Thank you. Did we have any other updates this week?
Hi, so I've prepared the PPT and I'll present it when you want me to.
Okay, yeah, go ahead.
Yeah. Should I present it like now?
Yes. Yeah, we can do that.
Okay. Fine. Let's share my screen. Yeah, can you all see it?
Yes.
Okay. So hello everyone. As you all know, I have been selected as a contributor this year for open source community stability project in Google Summer of Code. So the main sub-org under the main organization under Google Summer of Code is Alicea, and the sub-org under it is Orthogonal Research and Education Laboratory. So Sustain Hub is the name that I've given to my model, which I'm going to be making for the open source community sustainability, sorry. And along with that, in my proposal, I had just mentioned some things like my introduction and what I am doing, what I'm pursuing, etc. So what exactly is Sustain Hub? Sustain Hub is a model for improving the long-term health of open source communities. And basically, I'll be using 4 main agents: the maintainer, contributor, innovator, and the knowledge curator. And the tasks are assigned using the multi-armed bandit, and they're optimized through the 2 reinforcement learning algorithms, Q-learning and SA, which is known as Alicea. And I have introduced 2 new metrics: harmony index and resilience quotient. So the main goal of this whole project is to reduce the burnout, prevent stagnation, and promote sustainable collaboration. So this is just an overview of my entire project, and I've gone a bit into detail into a few of these things in this whole PPT. So the main motivation behind it is to change the sustaining of open source communities. We have some common problems like contributor burnout, uneven workload, etc. So why this project matters is we can build community resilience and stability using AI. So yeah, again, the overview of my project, that Sustain Hub is a model which is going to optimize the task distribution and contributor behavior. And based on the agent roles, reinforcement learning, and adaptive logic, I'll be working on this project. And again, yeah, I've just mentioned the goal again, like improving engagement, task completion, and system resilience. So coming to the main part, we have 4 agents: the maintainer, the contributor, the innovator, and the knowledge curator. And the earlier projects that we have had in OREL for open source community stability, they've had only 2 agents. So I thought that we can have 4 agents so that we can have specialization, which will improve the efficiency and sustainability. And then this is just a basic flowchart on like how we'll start. If the task is allocated, then we have to assign the task. If it's not, then we can recheck in the queue. Yeah, so I'll just read out this flowchart completely. Then once the task is assigned, if it's completed, then we can go to the end. Otherwise, we'll have to recheck. So again, talking about the agents, we have a maintainer agent, which has to review and manage the code. So it will view the pull request and approve it if it's correct. We have the contributor, which will write the code and solve the issues. So like example, we are contributors and we can make like pull requests and fix a bug or add a new feature. And innovator will suggest the new ideas, like share an idea to make the project better or easier to use, or something like create the issues. The knowledge curator is like it's supposed to help the contributors, or like the first time pull request or something like the guidelines. So we have some agent variables. The first one is the expertise level, which will go from apprentice to expert. Then we have the task load, which will decide how busy the agent is, and the success rate, which will track record for task performance. So our environment will be GitHub-like environment where we'll have like pull requests, issues, features, documents, and I'll try to completely duplicate or copy GitHub, like not copy, but yeah, so that my virtual environment is like that. And the tasks will be generated dynamically. So coming to the main motive, the main logic that we have used, it is reinforcement learning. So we have the multi-armed bandit, which I will be using for task allocation based on the success rate. We have queue learning, which will update the agent expertise via the rewards, and then a queue value will be assigned. And then we have salsa, which is state action, reward state action, which will optimize task switching when the agents are overloaded. So if you have studied reinforcement learning before, you might have come across this diagram a lot of times where there's an agent, it will perform an action in the environment and get a state, be in a state. It will get some reward. Again, the agent will perform some action and go to some other state. Then this will keep continuing till you reach your goal state. So reinforcement learning is categorized into two main categories. We have the model-based and model-free. And model-free further has two types, which is off-policy and on-policy. So we have multi-armed bandit, which I had mentioned before, which is going to be used for task assignment. So multi-armed bandit is an algorithm which will choose the best option by balancing between trying new options and repeating the successful ones. So trying new options is exploration and repeating the successful ones is exploitation. And how is going to help the agents? Because it's going to assign the tasks to the agent, which we have like maintainer, contributor, innovator, knowledge curator. Then it's going to choose based on the success rate of each of these agents. It will prevent overloading, but for this again we will have salsa, and then it will make task allocation smarter over a period of time. And this is like a simple diagram that explains how NAB works. Where this is a random agent, and then you can explore any of these, and then you're supposed to exploit the one which has the most. So ideally, this one has a value of 0.65, which is more than these two. So this is the ideal option. But then the agent does not know anything right now. So it has an equal probability of exploring each of these. So first we will explore, and based on the success rate, we will exploit. So this is what the optimal agent is supposed to do. So Q learning. Q learning is again a reinforcement learning method where the agents are going to learn by getting rewards. So the agent will perform some action, and based on that will get a reward, and then there's a queue table where the action, like the queue value, will be updated for each state and action. And based on this queue value, it's going to take the next action. So that's how queue learning is important, because you get some queue value, and then your queue value in a particular state for a particular action will help you decide what the agent should do in the next, like to go to the next state, like which action should it take. So yeah, that's what it's mentioned. It's going to help the agents, especially the contributors and the maintainers, to improve their expertise. The reward agents for successful task completion and make them better by choosing tasks. Make them better at choosing tasks. So this will lead to growth. And we have SASA, which is a learning method that helps the agents decide whether to keep working on one task or to switch to a better one. So it's useful when there's overload or there's stuck or when there's like or a deadlock, but when you have a lot of tasks to manage, then it's going to help them switch the tasks wisely, and it's going to balance the short-term and long-term benefits, keeping the tasks flow smooth and prevents burnout. So this is a simple diagram for salsa where there's a state and action. So you're in the state, you take some action and you get a reward. And then you go to state S, you go to a state S dash, and then again you take some action and then you will get a reward. So this is like a whole loop. So then we have the evaluation metrics to decide how well an agent is performing. So we have two evaluation metrics over here. The harmony index, which will measure the collaboration, balance, and progress. And then we have the resilience quotient, which is going to measure adaptability when the agents drop out. So why we need these? Because Harmony Index is going to ensure smooth collaboration by tracking balanced task distribution, like steady progress, helping prevent burnout and inefficiency. And resilience coefficient is going to check how well the system adapts when the agents drop out, ensuring continuity and long-term project sustainability. So along with that, in my proposal, I had mentioned a timeline. So it's not as detailed as the timeline which I had mentioned in my proposal, but this is like a very short one where in the first 2 weeks, I'll be working on the agent and the environment setup. In the third and the fourth week, I can be working on the multi-armed bandit. By week 5 and 6 can have the RL integration. 7 and 8 can have the metrics, and then onwards I can work on the GUI testing, documentation, and then buffer. Right. So for GUI, we can have Tinker, Flask, and if we have enough time, then I can think of some more interactive and attractive things like using HTML or JavaScript. So comparing it with the already existing models, since we have more agents in this particular model, there's going to be more specialization. It's completely adaptive because it's based on RL and there are no static rules. And yeah, you'll get real-time insights and interaction. So yeah, these were the names of the previous projects that have been worked on. Yeah, and this is what my project will deliver, like GitHub-like simulation, multi-agent logic and RL, harmony and resonance metrics, graphical user interface, and yeah, some non-technical things like documentation, blog posts, etc. Yeah, but thank you.
Well, thank you, Vidhi. That was good.
Yeah.
Yeah. So I guess do we have any questions from anyone in the group? Yeah, I have a few. So when you say you have an environment or a virtual environment, is this the building on the large language models of last year's project? We have reinforcement learning, sort of that we've been doing for a couple years. Does that build on that? I mean, what is the thinking on how to integrate that with what we have?
I don't understand. Like,
well, we have the project that we did last year, the large language models, and in that project, we're generating tasks and things like that. We also have the other reinforcement learning things that are in the repository that we've done the past couple years. I mean, we do have. I know it probably is a departure from that to some extent, but did you, when you proposed the project, did you? Yeah, did you kind of have those things in mind?
Yeah, I went to this. Yeah, like that's why I came up with like a different approach, because like maybe the solving approach is different, but then the task generation is going to be the same as how it worked for LLMs and the other projects that we have had.
Yeah. So what is your environment? Is it like something, are you building in toolboxes, or are you building everything from scratch, or how are you going to implement a lot of this?
I can, like, just in folders, like as you said, in the order repository, I'll be getting a folder to work in, and then the folder can have some like subfolders in it, and then the folders can have agents, and then the tasks can be in like JSON files or something, and the JSON files can have some generation in them.
Okay.
Yeah,
that sounds good. Yeah, and then I like the SARSA approach. Is this based on published work, or is this something?
It's not like I tried finding a lot of published works, but then it wasn't completely achieved. But then I had mentioned it from some article, I guess, or some paper, that it is quite possible that, like, for every action, if we get some reward, and then if we have a higher reward for an action which is being completed, we can focus on that. So we can just do that, and then there might be some actions which are not happening, so you'd focus on them later, so then that becomes your later priority. So your first priority is to complete the actions which are happening.
Okay. Yeah. All right. Thank you. That was a good presentation.
Yeah. Do you have any more questions? Yeah.
Well, I don't know. Morgan.
Yeah. Sorry,
Okay.
if I could. Yeah, just remind me again what the goals are here in terms of like it's not just a multi-agent software engineering problem, right?
Mm-hmm.
Like
Right, it's not.
it's so what are the metrics that we're going for?
So that's the harmony index and the resilience quotient, which is going to help us decide how much they can collaborate with each other. Like a contributor can keep contributing and a maintainer is just, what if the maintainer is not being able to merge a pull request, or if the maintainer is not being able to tell whether the pull request can be merged or not. So the collaboration between the maintainer and the contributor, for that we will use the metrics, right? So that we can see how well they're collaborating.
So is there so the harmony metric or some of these others, like is it kind of a communication problem, or like I'm just trying to remember for myself, like what what problem domains are involved here, and so when there's communication between agents, how are you deciding that they are having okay, so the merge rate is the dominant metric. Is that right?
So like, yeah, the merge rate should ideally, like, I haven't thought of that, but then I think I can change it while I'm coding it. So there might be a case, like if I have a maintainer which is not merging even one pull request, that means it has done something wrong. Like there is something wrong going on. It's either not understanding, or there can be a case where the contributor is not contributing correctly. So there might be one case where the contributor is not contributing correctly. So for that, I included the knowledge curator, where the contributor can know from the knowledge curator whether what it's doing is supposed to be done or not. And then, so this is the part where the contributor is not doing well. But if the maintainer is not doing well, for that so as you mentioned, for the communication problem, and just for the communication, actually, we have the metrics.
Yeah, no, I'm just trying to see it. I mean, because on one hand, it does seem like it's perhaps a software engineering. It's a straight software engineering multi-agent project, right? And and then it's like, are you actually just kind of looking at how a multi-agent software engineering project, implementation sort of breaks down in terms of communication, or in terms of the multi-agent parts, or like.
Okay,
sorry if I'm not saying this well. I'm just getting in.
It's fine.
But I am just trying to see where what aspects of the problem that we're trying to address.
Yeah, it's that only, the communication, and it should work properly. So
Sure. So I mean, okay. Well, that's good for now, and I'll definitely read some more and remind myself. I want to see. This is more my issue, not anything with your presentation.
Okay, sorry. I think I should work on better answers as well. Yeah, I think I should work on better answers as well. Sorry. Yeah.
Well, I'm just thinking about things like, what is it, like software engineering bench, or some other projects, like are we competing with them, or are we actually trying to do, are we
Not
focused on
competing,
something
but I feel
different, in
Yeah.
terms of, again, something about the code, when I think of sustainability, I think about kind of code maintenance, codes,
okay.
understandability, code. There's a lot of other ways you can imagine that. And yeah,
Yeah.
but thank you.
So like, no, it's okay. So I want to say something that previously you said, like, are we competing? Are we doing something? I think it's like computer science has this beauty of being so huge, and then there are so many domains in it, and then some domains, like a lot of domains are maybe they don't intersect, and some domains intersect so much. So like it's not like we have two sets A and B and then their union or something. They're like multiple sets, and then like there might be some aspects in common with this thing or some aspects in common with something else. So maybe you are comparing it to something and I'm comparing it to something. Maybe both of the things are right. Like, I don't know how to put it in normal words, but
Sure.
we can refer to it.
Yeah. I mean, this is also kind of a question for Bradley too, just in terms of like what aspects of sustainability do you like to emphasize, or
Right.
and yeah.
Well, I mean, yeah, we've kind of not had a. I mean, we haven't come back to that core question in a while, but I guess in the past years, people have focused on kind of, what does it look like if you simulate a project? What are the scenarios in which you keep people together as a community? What scenarios in which can they complete tasks collectively? So there's this collective agency problem or whatever. And, we've approached it in different ways. So with reinforcement learning, we've approached it with looking at the complexity of tasks. So not just one task, but like, a project with interlinked tasks. With the large language models work, we generated a bunch of tasks, and then saw how the agents were able to solve them basically. And so there are a lot of different ways you can go about doing that. I guess that's the sort of the core thing that we want to do. And this is not to say that's all you can do, but that's what we've tended to do because it's probably been easiest. And usually it's like GitHub contributions, and there are different ways in which open source communities work, right? Like there are different things that they have to do that are, completing a task. So not just GitHub commits or solving tasks or solving issues, but also with, discussions and things like that. The discussions part I think is interesting because you have discussions about things so you can solve problems, and then that's a little harder to sort of simulate and say this is sustainable. But that's the kind of thing I want to kind of do ultimately. But I think we do have, and this is for Vidhi, we do have existing reinforcement learning techniques. It'd be nice if we could have like some continuity in terms of how do we connect all this together.
Yeah.
Because there's this tendency to like have people working from year to year and doing different kind of approaches and then having it kind of be all over the place in terms of what we're trying to achieve. So, but I don't, I don't think we need to talk about that right now. We just have to keep that in mind. What is it that we need to do to, I guess getting things up and running is the first step. And then from there we can say, what do we want to use the code for? What are the demos? What are the use cases? What is the, yeah.
Right.
Yeah, I mean, I was just absolutely right. I was just wondering, like, yeah, in terms of the goals, like, is it to inform,
team dynamics, or like the best way for teams to work, you know, or is it, like I could see, or I haven't checked in. I've never used Copilot. I've never used any of these coding tools, right?
Yeah.
But I assume that they use metrics of like how many GitHub issues that they can satisfy, or like close.
Right.
And that's what I mean about like how much do you end up just kind of competing with coding agents?
Yeah.
And how much are you talking about kind of multi-agent dynamics?
Well, yeah, I think the multi-agent dynamics is kind of the primary thing, and then I mean, all the stuff with like simulating tasks or whatever is a means to an end. And we also, we did the active inference approaches as well several years ago, but we haven't been able to get that back into the fold. I mean, if it had not had anyone else say, "This is what I want to do," so it's kind of hard. We might try to follow up on that in another project another time, but
the Foresight Neurotech group this week met and had as a speaker someone ostensibly working on AI alignment, but from a very theoretical, multi-agent, game theoretic perspective, and it was so it was actually interesting in terms of what they showed as exponential complexity. They had, it was a very computer science perspective, but it did actually speak to multi-agent dynamics.
Yeah.
And again, it made me think about that AI economist paper from a while back. Because it was game theoretic, it's if you can have the agents engaging in economic behavior, then it's somewhat easier to model.
Yeah. Transactions, yeah.
And then you can anyway. Just thinking about that.
Yeah, I mean, we've kind of thought about different ways to do this too. So like, we have been doing like things like simulating tasks, but it might be better for like a project, or it might be useful to have kind of transactional type models, or like network type models where your agents are in a network. Each agent is addressable. They're doing things that are optimizing their payoff or whatever. I mean, there are all sorts of ways you can approach it. We don't know like exactly what motivates people, and that's kind of the problem. One of the problems. So we can't say for sure. All we can do is model it and say these are our assumptions, and that's what we have. And the assumptions can be very different. But and like with reinforcement learning, it's like, what is the reward? What is the policy that's best? The policy might be based on like whatever the motivation is. So like if the motivation is working together on a project, then that's maybe a better policy than like individual gain. Although in some cases individual gain might be better. And so it's not necessarily to say we're going to definitively say this is how you can optimize a community. It's more like, what are the different things, ideally, someone would come to this and plug in their problem or their specific community with their specific motivations, and then, would be able to simulate it. So, there are assumptions always in every model, but, maybe it makes sense to say, if you come to us with your assumptions, then we can simulate it and see what happens.
Yeah. Now it does. I mean, it does make me think of some of those. Is it NetLogo? It's the agent based.
Yeah. NetLogo.
Right. Yeah. Just ways in which they try to bring in, again, economic and kind of social aspects to the interactions, and to try again to, they are trying to model human behavior, even in very abstracted forms. Or certainly trying to give you some ability to interpret the trade-offs people are making between, say, social visibility as a motivator versus economic incentives or something like that.
Yeah.
And I'm just wondering how that's brought into this particular multi-agent simulation, if at all yet. But
yeah,
it's work in progress.
Yeah. We're just starting out. Yeah. So that's fine. But yeah, it was just things to think about on, like, how we want to, because I mean, ultimately we want to get everything kind of integrated, and that's a separate thing anyways. But yeah, so let's see. Thank you, Vidhi, for your presenting, and Morgan, yeah, thanks for the input. And then I don't know if Lalith had anything you wanted to share. I mean, you can present on your project at DevoWorm if you would prefer. But this is, if you want to have anything to add or have anything to mention.
Hello. Hi. Hi everyone. So I am thinking of I bought a presentation, but I don't know whether it is like crisp and good and all. But I can present it out to give a brief out about like my project,
Okay.
So if the time permits, I'll try to wind up in the time limit. But yeah.
All right.
So let me share my screen. Yeah. So hi. Yeah. I'm Lalith and I'm a master's student at IIIT Hyderabad, Brain Cognition and Computation Lab. And yeah, so my project is more focused on like modeling the neural developmental programs of C. elegans, where here we have, I am willing to focus more on like the growing hypergraph neural networks. So last year version, Mehul Arora, who had worked on hypergraph neural networks, where Mehul has developed some lineage hypergraph and spatial hypergraphs, where Mehul tried to, find out some, hierarchical relationships and shown us some plots. This time, I am more of willing to, fall on to the deeper level topic and try to understand how we can integrate this hypergraph neural networks when during the developmental process. So we call it like a growing hypergraph neural networks. How do you gonna do that? So that's main of my the idea. And going into the introduction part or the motivation part. So what inspired me is C. elegans connectomes, and this is the smallest organism which has like brain with 302 neurons. So this will help us to understand if we are able to model well the relationship of the system of a smallest nematode worm. I believe that we can develop some really good plausible neural networks that could lead us to a better integrate and biologically plausible neural networks, and that's more of my inspiration to work on this is. And yeah, the neural development program is basically a very high and temporally extended process where it characterized by certain sequential cells. Suppose we start from a certain cell division, then it happens sequentially and it emerges in a very hierarchical fashion. So this lineage specific differentiation, the spatial migration of the individual cells, and this complex emergence that we see, and the connectivity that happens later on. I mean, like each and every cells that divides and then it forms into a new tissues and then into an organism. And this process entirely, will give us a more detail and insight if we model with a neural network like the hypergraph. So what we see is, so when the previous works focus more on believing that there is a dyadic connection between cell to cell, but we're gonna explore that it does not need to have a specific dyadic connection, but when we have a hyper node or a hyper edge, so that can give us a multi-plausible connectivity where it says that it takes over the advantage of static dyadic connections, but it extends to a dynamically possible, and it can help us to provide a multi-relational modeling. So I believe that if we start off here, maybe that could help us to understand more detail about the hypergraphs and all. The developmental process of C. elegans. So the project objectives I divided into like 3 parts, where the foundation, the unification, and emergence. So the foundation focuses on how the different types of data, and suppose we focus on the cell division and for like multiple for like multiple nematode worms. So how do we can construct a network on top of it, a neural network? So what kind of connections do we need to have? What kind of relationships that we need to initially set up so that the foundation is laid strong? So then when we start unification, we use a certain type of suppose hypergraph neural network where there are specific set of mechanisms. The message passing mechanisms, and how is the message has been incorporated so that it drives across the network and it gives the right information to the right node. So this will help us to understand that given this structured data, then we are able to acquire these things. These set of features. And then emergence. So when at the end of the day we have to try to understand the integration of all these the features and everything into a hypergraph, and this has to be an emergent mode. So it has to start from a time step t and then it grows on. So this growth and the cell divisions, it has to capture all these details. So these are the 3 crucial steps I believe that that could make this the whole idea concrete. So I divided it into 3 phases. So my proposed framework focuses on the growing hypergraph neural networks, where we add dynamic nodes and hyper edges, and then we integrate these lineage, the spatial, and certain functional cues, such as in previous meetings we have discussed that the phase angle could be one of the key factor that could help us to determine the exact rotation. So we actually embed all those cues into the pipeline to get the whole structure, and then we design and learnable or data-driven simulation development. Based on these set of the connectivity. So how we're gonna see is how this model gonna evolve. How the network gonna be in the next time step. So we're gonna see that, and so this is just an intuitive diagram which I have used. So in the left side here we see that at a time step t, so the cell divides and the rectangular is like the parent node, and the small circular ones are like the daughter nodes. So here you can see that when the cell divides, so it divides into like parent and the daughter nodes, and later on during the development it has a different spatial structure. So it divides and there is a variation in the spatial development, and there is variation in the lineage tree and all. So in order to capture this complex morphological relationships and and the lineage information, so we believe that the proposed framework could give us like an edge to the existing line of works. So what is the mathematical intuition is? So here at suppose we develop a hypergraph neural network. So here hi is hit plus 1 is the next the time step of the hypergraph neural network, and HTI is basically the first T time step. So W1 and W2 are the weights that are gonna identify the modeling of this relationship. So the sigma is a nonlinear activation. So here the W1, the W2, and we gonna map these things exactly in a way that this could be more of a learnable function rather than a static developmental process. So we're gonna see that because from one organism to another it varies. So we have to capture the dynamics exactly. So here the W1 and the W2, these are the weight matrices that actually capture the dynamics, and the nonlinearity helps us to learn the network, and this whole integration will help us. This is simple. The basic form of intuition for like hypergraphs, and so when we design a dynamic hypergraph, the representation looks like we have a sequence where each node carries a feature vector. So what we call the features that we embed to the network, and it encodes the lineage depth, the spatial coordinates, and the molecular state. And based on that, what we're going to do is we use this H as a function which does this multicellular interactions, and it captures the complete developmental process such as cell divisions, the centrifugal fusions, and spatial neighborhood at a given time t. So this is just a basic intuition or the mathematical intuition. We can design like much complex networks on top of this. So yeah, so how can we have this higher order interactions, and what could be a good taxonomy for it? So I have looked into a 3 dimensions where one is like first is like hyperedge construction, where we give this lineage or the spatial or the functional or the adaptive information to it, and then we do the message passing. So in the previous videos, we have discussed like how a given hypergraph neural network can be modeled in multiple directions. So in that possibilities, we have borrowed some of the things here. So it's like when we integrate the linear, the spatial, and the functional or the adaptive type of hyperedge construction, then we have multiple ways of message passing mechanisms. And based on that, we can design our own type of temporal dynamics. How we're going to learn this, or how to learn these topologies or the graph. Complex graphs when they are like more of growing, because we don't rely on the static graphs and all. So it keeps on growing, and we're going to capture the higher order interactions accordingly. So the project timeline, I have split it in a shorter note so that it could be quick enough to grasp to everybody. But it's more detailed in my project report. But so here in the week 1 or 2, I'll focus on the setup, because the environment that we're going to use should be aligned with the environment that the previous report has been used, and I have to look into the literature that and design principles which could actually give us a more concrete results rather than stuck up thing. So we have to be more clear with the literature and the design and the entire setup, so that we are ready to get dive into the thing. So then we have to use the hypergraphs and the integrate and design a dynamic growth. See, like given a graph, how is it evolving using these set of initial setups. Setup in the sense it includes not just the programmatical environment setup, but it's more like what kind of data I'm going to use, what kind of the graph, while constructing the graph, what kind of the information that I'm going to use, what are the things that make me a structured format, so that it's ready to push into the when we start off the coding, and it's smooth process rather than it's a little bit of it shouldn't cause any impediment. So yeah, so the hypergraph integration and the dynamic growth, and then we focus on like various message passing models, and we evaluate like which one is like the right. So are we going to use like the attention networks, or like we use a different type of networks which can that's like more of graph convolution network, or graph attention network, or there are like new spatial elements adding. We're trying to focus on certain spatial elements, the local attention, the global attention. So we're going to focus on most of the different aspects there, and then we're going to see that how this can be scalable, how the temporal model can be scalable, and when we have a different line of data, and when we get a new data set, and when it's very well structured into the format that we use, so is it scalable to that? So can we use these different networks for the same model? We can use like different networks. Can it model the relationship? So that could be the 7 to 8 week. And 9 to 10 we're going to see that whether these whatever the modeling has like a proper alignment, and we're going to visualize all of them very nicely and see that okay, so it started here, this is how it has been evolved, and these are the connections that it had, and this is I mean, like, we understand the pattern exactly, the way it has been evolved, and when we visualize it, then we will have a more human intuition that how the model is working. For us, it will be more interpretable, and to understand that okay, the network is learning these parameters, and it's we can understand. Suppose it has a certain failure cases, when we can easily pick it out when we see like a good visualization. So that could be, we'll be focusing on like 9 to 10. And finally, I'll do the documentation and make the final submission, so that because this is one of the very exciting work, and it has been less seen in the field. So there is a very large scope. This can grow into a very good piece of work. So I think making this whole the week, like every week, useful can actually make this a really good project, and it can weigh a lot of it can weigh a bit more in the future. And yeah, so how can I extend this, and what are my future plans after doing this, and so understand the design principles, and use it for like so if I understand the modeling of the hypergraphs for a given C elegans, then we'll be able to understand okay, these are the connectomics levels that the that's how this has been learned. And when we map this to a neuronal level, when we try to understand how each and every neuron has been focused on. So right now we are focusing on developmental process, but later we can see how the functional connectivity happens when we have the activations from like each of the neuron extracted, and we have the all the open source data is very much available. We can see the activations that have been seen in like C elegans, and how are they, and we can see the alignment when we kind of use these set of models in order to understand not just the neural development, but also we can use it to understand the how is the organization of the entire neural structure, and how is the we know the wiring, the entire wiring of these 302 neurons, but functionally how are they activating each other, how is the correlation that we can see. So this can actually help us to design a new AI set of architectures where we can see that okay, although there is no direct connection, we can see there is a activation and the message communication from here to this node. So that can actually help us to understand more in depth. I mean, like design a better AI architecture. And when I say biologically plausible neural network design, so it's more of how the all the tasks that are integrated as a neuron it works. So we can use them to understand more in detail of how is the intricate structure of the neuron, how is the mechanisms, how is the the information passing happening, so that we can just put that into our framework, and then just see that not just for the C elegans, can it work for the Drosophila or for the next set of organisms. So, and then we can also understand the synthesis relationship that can emerge during this developmental process. So there is some of the work in the I'm trying to understand which Gordon Dick has sent to me, and we have been discussed with Professor Bradley in this direction, that there are like crucial 44 synthesis cells where the organisms during the developmental process it actually aligns and forms certain synthesions, so that it has a certain pattern. So can we observe this pattern during the neural developmental process? can we extract these patterns? I mean, like, can we know this? There is a certain behavior. It's not just an organism has a fixed head and tail here, and this is the network and all. So, do we have any, principle behind like this growth? So we can understand even that too. So yeah, so how this could contribute to INCF demographics. So first, it advances from the previous project which I have mentioned, and this unified dynamic modeling of lineage and spatial data is like one of the crucial steps, and the learnable hypergraph and the neural modules. So I mean, like different set of message passing mechanisms and different hypergraphs can actually play a crucial role in for the future projects and all. And the main motive of this open source project is it could be reusable with like a good visualization toolkits and all, and it's easy to go and play with whoever is like interested in. So yeah, so I think that's it. Thank you. If anyone has a question. Great.
All right, thank you. That's good. For interest of time, I just want to, maybe we'll talk more about these last couple slides in the DevoWorm meeting on Monday. Like, kind of going, because in the group there, we'll have, I think, more feedback on like what that means, implications of like some of the grander vision you have. Because we've talked about the stuff in this proposal in the meetings already.
Right.
So, and yeah, it's good. So yeah, I'm looking forward to seeing that get implemented over the summer. Sure. All right. Yeah. Thank you.
Thank you.
Yeah. So, I guess. Oh, Morgan, did you have something to say here?
No, somebody's just making a lot of noise in the background. Sorry.
Right.
My apologies.
Okay. Yeah, Jesse. So you have an update for us?
Oh, I mean, I don't need to say a whole lot today. I feel like I can't update this. These are two really good presentations. Yeah. And it's exciting to kind of hear from them and see where we're going and get started this summer season. So yeah, I'm it's a nice preview for that. And yeah, I think there'll be a lot of following up in terms of the Monday meetings for the fest. What I'll say right now is, and I hope I wouldn't mind so some of the interns for data and direction maybe will kind of be in these meetings sometimes. Some of them are more, I have a little more of a technical track that actually wants to deal with some of the open source related content and some that maybe not. So maybe in a few weeks they're here. But suffice to say, I have a lot of I'm basically at the end of the interview period. There's one person who had to reschedule later on, but it's been really great to see the applicants, and I'm really getting a sense of my take on things is a bit confirmed, because you kind of have the undergrads who have a little bit of experience and want more exploratory stuff, and then your grad students or other career folks usually have a little bit more sense of what they actually want to do in a project-based sense. It's a bit on where things are going to go, and there's this element of figuring out the best way to serve both of those communities, if you will. But I've been really excited with that. Some other projects as well that I'll probably say more tomorrow. Really briefly, I'll share my screen for like 2 seconds, probably more like 2 minutes. And let me just share this here. This is my big, ugly whiteboard that doesn't appear to be showing up yet. Okay, there it is. This is all just a preview. I have a post coming up where I go for this. Originally, it was from the Friday immediately after the event, or was it the Saturday, where Bradley and I kind of talked about this. Or I talked about this at a meeting, and Bradley kind of chipped in a few points. So I'm inviting Bradley to kind of be a part of it, but I organized the whole discussion into this space. Yeah, it'll be in the post as well.
And I broke it down into background, leading and mentoring for the event, like leading the event itself and mentoring, things about presenting specifically, and then also some of the takeaways from the event. But I was breaking it down to these 4 categories, and it in a much more coherent sense, it became like 30 minutes of actual discussion. So I basically just like, okay, I'm making this a discussion. I'm going through the points, and I am releasing the article hopefully later today and experimenting with some kind of like audio podcast version of it for Substack. Because I mean, you're doing a lot more of that this summer. So for people that want to talk about stuff or projects or often kind of these opportunities to kind of have a pretty comfortable environment, in-house feel for like, let's give you a practice for interviewing about the work you're doing. Like if you want to get either the public speaking aspect of it or just the writing aspect to communicate to the broader audience, I'm trying to offer more of those things because now you don't have to be pitching all the time, but just getting that familiarity is important too. And then that's why it's so great that you both did what you did today, because the presentations matter and updating matters and getting used to conveying the ideas matters. And it's definitely performance art. The more you do it, the more regularly you do it, the better it gets. I'll leave it at that. But any kind of initial questions about this? Because I'll cover it a lot more maybe tomorrow or next time. I know we don't have a lot of time today.
I mean, this looks fascinating. I'm not sure. I like this kind of synthesis of things after the fact, and I don't know what it all means, but that's the process of kind of unpacking what you've learned. Like, if you go to a meeting, or if you sometimes if you have a series of meetings, this is the thing that we have in our group that's so difficult to get our head around. Is like we have all these meetings and we have like a lot of things we talk about, and it's like, what is the higher level lesson here? Are there things between meetings? Like we've had this year so far, we've had a number of different sort of, meeting to meeting themes that have kind of been revisited because we have the conversation, there's something of value, we continue on with it. And, getting that all kind of synthesized is always the challenge. And sometimes it's different for different people. Like, what are you getting out of it? What am I getting out of it? I imagine if I had gone to this event, I would have gotten a different list on the board. It may have gotten different categories. And, maybe that's okay because you want to have, different takeaways. Like, what did I find interesting giving my expertise? What did you find interesting given your expertise? But it's important because, you don't know how these things fit together until you actually do the exercise. That's why I like this sort of thing. Yeah.
I would love to actually make this an article that's submitted to some kind of I don't know if it'd be a really grading article or some like chronicles of higher education, something that's a bit unlike how academia or knowledge generation is done at a kind of institutional level. But to your point, and I remember saying this basically last year and the year before, I was saying I would love to make an article that advocates for having more intentional synthesis time at the end of meetings. Like this is a big thing when I was like last year basically when I was at Oxford Internet Institute for the Inclusive Gaming Conference, and I was craving this bigger time at the end, and it's tough because when people have when you're on a tight schedule, you have a short conference, it's kind of you get in, you get out. Like I get it. There's many logistical issues for those who run events. You know what I'm talking about. And if you haven't run an event or chaired a conference or put together something, just take my word for it that it's real hard. And you kind of just want to. There's so much pressure on the organizers to just do it and get it done and not have any train wrecks. But from a knowledge synthesis standpoint and a recapturing standpoint, what I'd like to really pitch or propose in this article, and we've kind of written it in our minds already. We just need to put it to work. What I'd like to propose is like, how do we create this synthetic time? And I think there's a lot of applications. How do we create synthesis at the end of the event? And like Bradley kind of said, his takeaways from this particular event would be different. But this is something that we've been thinking about in our labs for a long time. It kind of fits a little bit with meta-science, a little bit with pedagogy in general, a little bit with interdisciplinary spaces. How do we make that? And it kind of ties into some things I'm doing with Frontier Map also. By the way, I didn't get to attend in person because of some travel issues, but let me pull this up so I can. Oh boy! Speaking of a similar topic, man, where is my stuff? Here we go. Speaking of a similar topic, there is. Sorry. Yeah. Okay. Suffice to say, that's an article I'd very much like to write, and on a minor plug to what I've done this week that ties into Frontier Map, which is what I just said, and everything else. Here we go. Yes. I don't know if you can see this very well, but basically, I was invited to accepted at the Education Innovation Expo. I really wanted to go in person, but let's say a lot of travel plans and coordination issues prevented me from doing that. So I'll talk more about this tomorrow. But basically, this is sort of the main thing, and I think what I'm saying fits with that. Like, how do we try to do learning in these contextual developmental trajectory where case spaces? And I've mentioned orthogonal lab as one of our case studies. Like, yeah, we care about this. How do we do this in education? So the premise of that event was innovation, education, how AI helps stuff. So more about that tomorrow. But I think there's so much here in terms of, how we do stuff, and to circle all the way back to the MIT event itself. I don't know. It was both a lesson in pitching and then this unexpected just experience of running an event, seeing the judges. Charnwar did a great job. As I keep part of why I keep talking about it, making content about it, and reflecting and like doing the writing work is like I keep absorbing more stuff every time I touch the material. So that's what that is. I'll leave it at that. Things to discuss tomorrow. I'm trying to get out of my screen here, but that's all for me. And more questions. If you have any questions or anything you want to follow up in Slack, that's all for now.
All right. Now let me share my screen real quick. I have two more things before we go. So the first thing is that I put up a blog post on our lab Medium. This is the Oral Group Medium. This is just welcoming everyone. Google Summer of Code Scholars for 2025. It's Lalith, Jayadratha, and Vidhi, and I've just kind of put the titles of your projects and just kind of noting that we're doing the open source meetings. The other thing I wanted to point out is that we have this. So the way our websites work is we have like two main websites. DivaWorm has a website, and then Orthogonal App is a website. And we have these different group websites. So DivaWorm is kind of like a group website. And then another group website is this representational brains and phenotypes website. So this is like a lot of the work we're doing on agent-based modeling, computational agents, and the like. And so, a lot of the stuff we've done with developmental brain vehicles is here. A lot of the stuff we've done with MetaBrains is here. And, this is kind of like DivaWorm being our kind of computational developmental biology group, this is sort of like an agent-based modeling, artificial intelligence, artificial life group. So, we have different things under this. So this is linked off of the orthogonal website. We have different categories here. So we have cultural computational modeling. We have growth and form, cybernetics and complexity, which includes a lot of the stuff with developmental brain vehicles and neurosimulation, the allostasis machines papers that we've published, the metabrain models papers we've published, and then that's like agent sort of internal nervous systems and agent-based modeling. And then I have this new category. I have to fill this out: agent-based modeling, large language models, active inference. I didn't put reinforcement learning in there, but I'm going to. And so we have all of this here. So I'm going to update this site. This is going to be the site kind of for a lot of the agent-based modeling, developmental AI stuff that we're doing in the group. I also have another website for the phasic and cybernetic stuff, and that is I haven't shown. I might show that tomorrow, but it's less fleshed out. But anyways, I just wanted everyone to know that like those are kind of their structures in terms of websites and public facing things. And so I don't mean for everyone to go through and examine it, but I do want to point out that I'm going to try to be more intentional about getting things in there and advertising things. Although we have a lot of things in the websites that we kind of get buried.
So. It is so hard. Like I have to say every time this comes up, like when I was a student or like undergrad, I look at this like professionals' websites and be like, man, like you're doing so much stuff that's not on here. And now that I'm like in the business, like holy crap, like
it's hard to keep up. Yeah,
it is so hard to like know where to put things and keep it updated, and then you like competing with what you actually want to be doing, which isn't the PR part of it.
Yeah,
like so I'm just like, yeah, like when you get the wave of enthusiasm, do it, you gotta ride it, because the wave of enthusiasm to actually share what you're doing is not always there, and it's hard. So good. I'm glad to kind of be rowing the same boat with you on that part, Bradley.
Yeah. All right. So thanks for attending. Yeah, we'll have our meeting, our Saturday morning meeting tomorrow, and then DivaWorm on Monday.
Cool. Good stuff, everybody.
Yep.
Next time.
See you later.